Hello, friends. You know the Winjix software for crystallography. Using Winjix for solving and refining crystal structure involves several key steps, from setting up the data to solving and refining the structure. You know general overviews of how to use Winjix. Though I would recommend referring to the software specific manual user guide for details, step by step instruction. Prepare the data, obtain X-ray diffraction data. First, you need to collect the X-ray diffraction data of your sample. This is typically done using an X-ray diffractometer. Data format is important. Ensure your data is in compatible format for WinGX. The software usually works with the files like .scale or .xyz for diffraction data or model coordinators. Second, load the data into WinGX. Launch the WinGX program, open WinGX on your system, import the data. Use the software interface to import the diffraction data file, often .scale or .date, and this can usually be done through the file menu or a similar interface depending on the version of WinGX. Check data quality. Before proceeding, verify that the data has been correctly imported by checking parameters such as symmetry, space group, and completeness. Symmetry, space group, and completeness. Then solve the structure. WinGX allows for both direct methods and potential method for solving the structure. You know direct methods if you have a strong enough data, high resolutions, good signal to noise. A strong enough data means high resolutions, good signal to noise. You can use direct method to solve the phase problem and determine the initial atomic positions. You will typically choose solve crystal or solve structure or a similar option. Select the direct method and let the software attempt to find the solution. Potential method. If direct method does not work or don't work well, you may need to use potential map or other techniques. Choose potential functions or the similar tools in WinGX to generate the electron density map. This approach can be useful if you know something about the symmetry of the structure. For example, from a partial solution. You know the refining the structure, refine the model. After solving the crystal or structure, which will which will give you an initial model. You can begin the refinement process. Use least square refinement. This is one method, least square refinement, or other fitting techniques provided by Vengeance. This step optimizes the position of atoms to better fit the observed diffraction data. Adjusting parameters like atomic position, thermal parameters, and occupancies. Refinement is typically an iterative process where the software calculates a R factor or goodness of fit to measure how well the model matches the experimental data. My friend, check for convergence. Convergence, write it down. It is also very important term. Keep refining the model until the fit improves or converges. The Winchix will provide feedback on the quality of the refinement through various metrics such as the R factor and other statistical output. Now, model validation check structure geometry. Ensure that the refined model adheres to the reasonable chemicals and geometrical constraints. Bond lengths, bond angles, electron density maps. Examine the difference electron density maps to identify if there are any residual or errors in the model. Symmetry and space group. Confirm that the final structure matches the expected symmetry and space group based on your data and the chemical information. Visualize the structure. The Winjix provide visualization tools to display the crystal structure. You can visualize the arrangement of atoms in 3D, display the electron density map, and inspect the structure visually. You can use the graphical interface to rotate, zoom, and manipulate the structure for better analysis and presentation. Save and export the final model. Once the refinement is complete, the model is validated. You can save the final refined coordinates, usually in pdb.cif or .xyz format. If you need to perform further analysis or publication, you can also export the diffraction data, the final R factor, and other relevant details. Advanced features, that is the option. Advanced symmetry handling. Winjix allow for sophisticated symmetry analysis, which can be helpful for you have dealing with the complex or low symmetry crystals. Handling disorder. In case of crystallographic disorder, multiple orientation or positions for atoms. Winjix provides tools to model this disorder and refine the model accordingly. Electron density analysis for charge density studies. Winjix can be used to compute electron density maps and analyze charge distribution. So helpful tips, practice with the example simple structure. If you are new in crystallography or Winjix, It's often helpful to start with the simpler structure before taking complex one. Consult documentation. Winjects come with the documentation and manuals, which will provide detailed information on each step of the process and how to use the software effectively. Community and forums. Look for crystallography forums or community groups that use Winjix to exchange tips and tricks. If you encounter any specific problem or need help with a particular part of the process, example structure solution refinement, feel free to ask for more details.